Great. Hello, everyone. I'm Jiwei Li from Stanford University, and this is joint work with Ritter, Cardie, and Hovy. The focus of this work is on how we can automatically extract personal major life events from the user-generated contents on social media. So before getting started, I'm going to spend a little bit of time describing what life events are. I think generally there is a list of generally agreed things that should be treated as important happen in individual's life, like getting married, or you giving birth to a kid, or you getting a job, or being accepted by some university. And when we look at online social media like Twitter, and people indeed publish a lot about their important things happened in their life. For example, someone would say, okay, she's got engaged, and some people would say she's got accepted by Harvard University, and some would say he got a job offer. So the problem we are particularly interested in looking at in this work is not only aligning all these types of tweets to one specific major life events that it was talking about, but generate a more structured data format to describe these events. For example, if someone said, I was accepted by MIT, we would not only like to align these tweets to one type of event called, say, university admission, but also want to extract some event properties for this twist, like which university this user was admitted to. The answer should be MIT. For another example, if someone say she's got engaged to someone, we would like to align this twist to the event type engagement. We also want to extract some event property like who is she engaged to. Also, if she says he got a scholarship, we want to extract, okay, what is the scholarship, who gave him this scholarship, and how much is the scholarship. So what we want to do is extract these types of personal life events. I think first it's going to facilitate users to better understand the experiences and the what happened to the users that they are interested in. Also, it's going to facilitate a bunch of downstream applications like friend recommendation to recommend users who share the similar life experiences to become friends. Also for online advertising to say, for example, to sell, say, a birth care product to expectant mothers. Here's the outline of this talk. I'm going to first identify a few key challenges involved in this work, which kind of make this problem a really tricky task, and which corresponds to for lack of work in this specific problem. And then I'm gonna overview the system we proposed, and then detail the algorithms and experimental results, followed by a very brief conclusion. So the challenge involved in this problem is, the first key challenge is like, even though there is, as mentioned before, there is a list of kind of generally agreed important things happen to a specific person, like getting married or say giving birth, but major life events is still an ambiguous concept. Different people would have different opinions about whether, say, you're buying a car, or you're getting sick, you are going for a holiday, or you're participating in a kind of sports meeting. People's opinions would be different about whether these stuff should account for kind of major life events. Additionally, even for one specific type of event, the situations might be complicated in terms of different scenarios. For example, if I participating in a sports meeting isn't a big deal, but if someone win a kind of worldwide champion, it's going to be a very important event in his life. For another example, if I got a cough, I got sick. If I got a cough, it's not a big deal, but if I got a cancer, it's going to be a huge problem. For the second challenge is kind of the noisy nature of data on online social media. It's like in this specific task, if we enter the keyword I get married in this kind of Twitter search interface, and we can find that 90% of the return results are not what we are interested in. I'm going to give some examples. Someone would say, okay, I want to get married. It's kind of like the random imagination or thoughts. It does not correspond with what happened to this user or speaker. Also, someone would say, two couples are here or get married, which is referring to somebody else. It's not about this author, the speaker himself. Someone would also say, my dream's dead when I got married, which corresponds to kind of event happened in the past. It's also not what we are interested in. Oh, sorry. Here. So the second challenge here is whatever machine learning we are going to use, we need some kind of gold standard data to provide some supervision. But in this specific task, first, we do not really have that labeling criterion due to the ambiguous concept of major life events, as I mentioned before. And also, even though we have these kind of labeling criteria, life events are very sparsely distributed if you consider the great sum of topics discussed on kind of online social media. Also, there are a lot of kind of rare events that you cannot cover in your labeling data. So what we are going to do. So the key idea of this work is like, instead of directly modeling what people would say about their major life events, we take one step back. So I'm going to ask this question. So if I report something like what happened, like the major life events in my life, if I said I got accepted at Harvard, what would you say? What would you respond to what I said? I think you get it. It's like you would respond like, congratulations. So the key idea of this work is like we are trying to use these types of congratulations and condolences speech acts to obtain a relatively clean data set, which can provide some sort of supervision for our later event extraction task. And also, if you consider these speech acts, it could be congratulations. People would maybe respond to these life events by congratulations, great, or fantastic, or awesome, or cool. On contrary, in response to bad news, it could be I'm sorry to hear that, or that's terrible. So what we are going to do next is we get started with a few kind of seed samples, like congratulations, fantastic, or cool. So we fit these tweets, or fit these seeds into kind of conversation data in Twitter, and we fetch the tweets which are responded by these seeds. So we think we would wish that the kind of the life major events are kind of embedded in these kind of tweets. So what we do next is we'll first run a kind of LDA model, and we get some word clusters, and we wish that the clusters identified by LDA may correspond to some of the major life events topics. And what we do next is we just sit down and we manually examine the topic, the top topic word distribution for the clusters, and we try to select out those meaningful word clusters that corresponds to the major life events. As the seeds, the starting seeds might be kind of limited. We kind of employ kind of semi-supervised data harvesting techniques. The key idea of which is like you get started with some seeds. You use these seeds to harvest some data. You use this data to train some patterns, and you use patterns to get more seeds, more data, more pattern. You do this recursively. So what we do here is we have the kind of the topic word distribution in terms of different kinds of identified major life events. And we use this topic word distribution. We run a kind of stream LDA model, which is a variation of LDA that kind of address the property of stream data, and we harvest more text. We use this more text to collect more kind of expression seeds, and we use these seeds to harvest more tweets. We kind of, again, we run LDA there. We do the manual identification, and we do this recursively, and we try to harvest these data. So at the end of, we run this step for 3 times, and at the end of the bootstrapping, we wind up with about 800,000 tweets that corresponds to this major life events. And among all these kind of word clusters, we manually identify about 42 different categories for life events. So here are kind of the the word clusters labels are manually given, and as we can see, the cluster may include birthday, job, wedding, award, sports, and anniversary. And if we examine the top word for wedding, we have the top words may include wedding, love, ring, engagement for graduation. It includes a graduation school and college. So now we are kind of equipped with this topic word distribution in terms of different types of major life events. But now we are still far from our goal. So based on what we do next is based on these kind of word clusters, harvest data, topic word distribution, we propose a system. So the system is comprised of three pipelines. So for the first pipeline, we call it the kind of personal life event identification process. It's like given any tweets, we try to align each of them to one specific life event if it does correspond to that event. And also we want to filter out those random stuff. For example, if the system takes as input 3 tweets, I had beef jerky for lunch, which is kind of random, does not correspond to life event. And the other is like, I got married to Tom, my friend Chris got married. So the first system is gonna throw away the twist, I got beef jerky for lunch. It's gonna preserve the rest two, and assign the label marriage to these two tweets. And the second pipeline, we call it self-reported information identification, which tries to select the twist which is specifically talking about the user, the speaker himself. For example, in these two twists, I got married to Tom and my friend Chris got married. We are gonna throw away the twist my friend Chris got married because it's not about the speaker himself, and we want to preserve the twist I got married to Tom. And for this third pipeline, we call it kind of event property extraction, that we try to extract the event property. Like in this specific twist, we tried who is the speaker married to, and the answer is Tom. So for the pipeline first, first pipeline for personal life event identification, we train kind of multi-class classifier based on SVM. The positive examples are for each categories are selected from the pre-identified data we harvested, and the negative examples are just kind of random twists. We use kind of features like topic tweet probability, which is calculated based on the topic word distribution we harvested, and also kind of dictionary. Dictionary includes the terms that are kind of the top words within the pre-harvested data set, and also kind of normal features. And as we can see, we split the harvest data and as training and testing, and as we can see, if we combine all these features, especially adding the features extracted from the harvested data, we get kind of better precision recall. And also for the second step, for self-event information identification, we also inactive examples is comprised of the following kind of scenarios, like now self. It's like talking about somebody else, or maybe the random thought, I wish to do something, which is not we're interested in looking at, and also the past tense. So what we do is we select the positive and negative, manually examine these positive and negative training data from the pre-harvested data set, and we kind of train a binary SVM classifier and incorporate some features like tense, like factuality, which is kind of a list of words like would, could, can, and also some the presence of the keyword I, and also dependency parts. These features was trying to figure out whether the twist is talking about the speaker himself. And also the common features between bigram, SVM, and to identify those twists that are specifically talking about the user himself. And as can be seen, as each of the features kind of respectively address the each of the negative examples, when we combine all these features, we get better kind of accuracy. And for event property identification, what we do is we train a CRF model. We view that as a kind of token level identification problems, and we sit down and label some data in terms of the event properties for different types of events, and there's about human labeling, and we train a CRF based on these kind of features. So to conclude the system, our main comment is like, what benefits can we get from the congratulations and condolences speech acts? It's like we can get a relatively clean set of data set that can provide some supervision, not only for the personal topic identification, because each of the harvested topic cluster corresponds to one specific kind of personal topic. It will also provide some clean data for self-report information, as it kind of largely narrows down the candidates for human labeling. For example, if some user said, "I wish to get married," people seldom respond with congratulations. So in this case, it's narrowed down the candidates for kind of human labeling. So here's kind of end-to-end experiments. We tried to construct a gold standard life event data set. We try to ask users to label their own tweets, or we also try to ask Turkers to label the other tweets. We assign each of the tweets to 2 Turkers, and as we mentioned before, because of the lack of the kind of the labeling criterion, the labeling do not really show the inter-agreement, but authors made this final decision. We collected about 900 positive tweets and 60,000 negative tweets. I would say the data set might be problematic because we try to use this data set to kind of show whether our model works. So for baselines, the first baseline is kind of just supervised model, like we just trained a supervised classifier based on kind of the cross-validation on the label training data. And then we combine the supervised model with the self-information identification classifier trained in our step. And as can be seen, for supervised method, it doesn't work at all, which is reasonable because there are so many types of live events being discussed in online social media, which the training data could not cover. And when we encountered, new types of events in the testing data, the supervised classifier will never work. Another thing is, does the bootstrapping help? We train a classifier for each steps of bootstrapping and apply this classifier to the gold standard data set. And as can be seen, when the bootstrapping goes on, we kind of get better recall at a little bit sacrifice of precision. So conclusion, in this work, we studied the live event problem on Twitter. We proposed a framework based on congratulations and condolences speech acts for data harvesting, and we explore different types of features and algorithms for this specific task. So the key idea, in conclusion, the key idea of this work is we try to solve this problem based on minimum human labeling efforts, which means inevitably the methods might be problematic first, we are kind of restricted to the event types identified by these speech acts, and there must be a ton of kind of major life events that people do not usually respond with kind of congratulations and these speech acts. And also, not all responses correspond to life events, and maybe the error can accumulate in this pipeline system. So this is joint work with thanks to the co-authors, and thank you.
Questions to Jiwei?
Thank you for the interesting talk. I was just wondering about just simple bag of words, features for doing the identification, because somebody is sick or has a deceased relative, you get words like ask for your prayer or something like that. So I was wondering how well these kind of features would work.
So first, whatever. So I think the first problem is how you get how you get the training data for the sick event category.
I understand that the way that you got the training data is very, very clever.
Right.
I'm just saying now that you have the training data.
Yes.
And you're doing now the classification of learning the model, then still going towards the features might still be quite valuable.
Yes, right. But yeah, exactly. Yeah, I understand your question. So I think the answer is if we only train the classifier based on those, say using back-words features, using the pre-harvest data, it's gonna maybe, for example, if I say, just as I said, kind of negative example, is if I say I was sick, or my friend got sick, or and as for these examples, these should not be treated as the major life events that happen to that specific user. But if we just use surprised kind of classifier, it's gonna assign a very high weight to the word sick, but it's gonna identify all these sick, say my friend got sick as a positive example. So that's maybe made the wrong decision. So did I answer your question? Okay, thanks.
Questions? So I have one question. So in the this congratulation, it has to be in reply to something else. So for example, it could be that I mean I don't mention that I have a new job or something, but somebody still knows about it. Says, hey, congratulations to your new job, and then I say thanks. Sort of. You're not using at the moment, right?
I'm using that.
Are you using it? So it doesn't have to be. So the congratulation doesn't have to be in reply to something else. It can also be the start of a new thread.
Oh, I see. No. It has to be. It has to be used as the replies to some other previous text.
I see. So in the extreme case, when I say, so for example, this is something that we've looked into, like rest in peace, so and so. This is usually not in reply to I just died or sort of or so. So
Right.
so this you wouldn't catch, obviously. No. Okay.
No. Yeah, that's one of the weakness of the model.
Yeah.
Is cannot. If something that are not responded by these kind of speech acts, the model can never capture these stuff.
No, I mean, but for example, if maybe I get a new job, but I don't tweet about it, and somebody still says congratulations, and sort of it just, so you wouldn't have to change a lot. It's just that the thread starts. The thread starts with a congratulations, and then I say
Right,
thanks.
right.
It doesn't start with I got a new job, congratulations, thanks.
Yes. No, we didn't consider
Anyway,
that. Sorry.
yeah.
Yeah.
No, it's interesting. Well, I have one more question. So, of course, it would also be interesting to look at at certain social features, right? Sort of, so who actually congratulates? So this could also be
Right.
give you some signal, right? As like to how major this is, or even if it's major at all, maybe there's some person that tweets,
Maybe
"Hey, I got up
yeah.
this morning," and somebody says, "Hey, congratulations! That's such a great feat, that you get out of bed or something."
Right, or maybe the closeness of the.
Yeah,
between
exactly. Sort of,
users.
also,
Yeah,
right? So,
yeah.
sort of, but this you haven't
No,
looked at.
no,
No,
we
okay,
never
that
looked
would be interesting.
Hi, it's very good work. I just wondered, since you're using speech acts, if you chose a different group of speech acts, do you think you could find a different type of event?
I'm sorry.
I know you're looking for life events,
Right.
but if you chose different speech acts,
Right.
rather than congratulations or condolences, do you think you could induce
Yeah,
maybe not
exactly.
life events, but other type
Right.
of events?
Right, exactly. It's like, yeah, because I think the harvested data is, total. It's kind of 100% decided by your kind of these speech acts or your starting Cs. We try to kind of address the limitation of this kind of the starting Cs by kind of using the bootstrapping strategy to get more Cs. But your question is great. It's like, yeah, if we get started with some other kind of, for example, if we get started with sorry to hear that, and we do not use kind of congratulations, and all the harvest data may be about sad news, or whatever you do, the kind of LDA or stuff, all the identified clusters would be about bad news. Say somebody passed away or a failed examination, all these stuff. Right. I think that is one of the limitations of this work. Right.
Okay, so let's thank Jiwei once more.